You are welcome to SK Pass International College. Please like this video, share, comment, and then tell your friends to also subscribe to this channel. We are going to continue with our lesson on chemical bonding. In my previous video, we studied about the types of chemical bonds. And in this video, we are also going to look at a particular type of chemical bond, which is ionic bonds. We started in the previous video. So if you have not watched my previous video, please try to watch before watching this very video. Thank you. We said that when you say ionic bond, normally there's an electrostatic force of attraction that exists between a positively charged and then a negatively charged to form a stable compound. So you should note that anytime there is ionic bond formation, there is one electropositive and an electronegative element coming together, and the force that exists between these two atoms is what we call ionic bond. Today we are going to look at, so we give an example like sodium and chlorine. This is positively charged, this is negatively charged. So the electrostatic force will exist between these two. Now in ionic bond formation, we need to note that there is always a total transfer of electrons from one species to the other. There is always a total transfer of electrons from one species to the other. What it implies is that in ionic bonds, we don't have anything like sharing of electrons, but rather a total transfer. But when it comes to covalent bond, there will be a sharing of electrons, which we'll get there soon. So you see clearly from here that this sodium has a valency of 1, this chlorine also has a valency of 1. Since they are 1, you are not seeing it clearly, but I'll give different examples. This sodium will transfer its valence electron to this chlorine, and this chlorine also transfer this. And they come together as stable compound, that is sodium chloride. So this sodium chloride is an example of an ionic bond. For instance, let's also write for magnesium and fluorine. Magnesium has atomic number 12, so if you write the configuration, you can use the SPD notation, but the core will tell you 2:8:2. This will also tell you 2:8:7. So automatically, this will lose this 2, this will also gain 1. These two people coming together, you can see this clearly, that this is having 2 and this has 1. So there's total transfer of electron from this 2, magnesium is transferring its 2 to chlorine, and chlorine is also transferring its 1 to magnesium, so that they come together as a stable compound. And they come together as this magnesium chloride. So you can attest to the fact that this 2 was coming from the magnesium, but it has, because they are forming ionic bond, it has transferred the total electron of this magnesium to chlorine. So that is the concept of ionic bonds. So one thing we need to note about ionic bonds is that the bond is formed between electropositive and an electronegative, one positive and one negative. Now let's look at some characteristics of ionic bonds. These properties, we can refer to them as the physical properties of ionic bonds. Looking at the state, we can see that this ionic bond exists in their solid state, so they are crystalline. So ionic bonds are crystalline solids. They exist in their solid state. From this concept, we can see these bonds, we can say that they have high boiling and melting point. So this is one thing we need to know. And because of this, they are having delocalized electrons. Okay, since they are having charges, they are delocalized. So the charges move. As a result of that, we can say that these ionic bonds can conduct electricity. So we can say they have high boiling and melting point. This is both for the core and then electric. Ionic bonds have high boiling and melting point. They are delocalized, therefore they can what? They are in their molten state, they can conduct electricity. Alright, so these are some few properties of ionic bonds. Now we are going to talk about this scientist who propounded the theory for these ionic bonds or molecules to be represented in their stable manner. And this scientist is called Cousel-Lewis theory. So we are going to use the Cousel-Lewis theory to draw the Lewis dot structures for the various molecules, starting from the ionic bonds. We can draw for so many molecules. Molecules which are not even ionic can be treated. So since we are talking about it, let's talk about it in general before we move on to covalent bonding. So we are going to start with sodium chloride. What is Cousel-Lewis trying to say? This sodium and chlorine coming together will form sodium chloride. So according to Cousel-Lewis theory, all that is trying to say is that write the electronic configuration of the sodium, which we have done already in our previous video. But if you are writing a core is 2:8:1, then this will also be 2:8:7. So I've already said that in chemical bonding, we are only interested in the valence electrons. They undergo bonding. So looking at this, these two are called core electrons. Core electrons. And this is the only valence electron. So sodium has one valence electron. This chlorine has these two. So we have 10 core electrons, but 7 as 8 valence electrons. So we are only interested in this. So Cousel-Lewis theory is saying anytime we have a structure like this, represent that valency with a dot. That is why it has the name the Lewis dot structure. It's a structure represented with a dot. So we are only interested in this one. So sodium, looking at sodium, if I have sodium like this, for me to draw this dot structure, I'm just going to use this. Remember that whilst we are at the basic school, in writing electronic configuration, we could either use a dot or a cross, like this. But because of the scientist who propounded this theory, he preferred using a dot instead of a cross. So we don't call this a cross dot structure, but it's called the Lewis dot structure. So we do not use cross in this presentation. We only use dots. So sodium is represented with only one dot, indicating that this is the Lewis dot structure of this sodium. And I'm reacting this with chlorine, which has 7 dots. 2, 4, 6, and 7. Now you realize that this is now more electropositive, or this is positive and this is negative. So when I want to bring these two together, for them to be stable, we have said that electrons prefer to be stable. So this sodium is having 2:8:1. So for this sodium to be stable, it will have to lose this so that it will have 8 at the outermost shell so that it will be stable. For this chlorine to also be stable, it must gain 1 so that it will also be 8 as the valence electron. So this is what is happening. There is total transfer of this electron from this species to this species. So in actual sense, this is the one here. So we have other. So someone will see, if there is a total transfer of electrons, it seems there is some form of sharing. Yes, there is some characteristics of sharing in ionic bonds, which we'll talk about that in our previous or in our next video. We will be talking about what we call polarization, polarizing power, and then polarizability. When you get to that concept, you will understand and know why the need to understand this concept very well. So looking at this, actually, you can see that this chlorine is now full, 2, 4, 6, 8. So it is having full state. And this has been able to donate each one, so it's also full here. So these two will come together as a stable entity. So this is sodium chloride, and we can say this sodium chloride is stable. With this concept understood, I would like you to draw the lowest dot structure of the following and write your answer in the comment section. If you are able to answer it correctly, just write yes. This is magnesium chloride. Now, if you look at this magnesium chloride, if I should write this is magnesium 2 plus, chlorine minus. But in this case, this magnesium is only having 1, but there are 2 chlorines here. So if you are to draw, this is having 2 dots, magnesium, 2 dots like this. But this chlorine has 7. 2, 4, 6. There's another dot here. 7. There's another chlorine here. So you can see, for this to stay together as a stable compound, they will all have to donate 1 each. So this is donating 1 to this. This is also donating 1 to this. So you can see this magnesium is donating to this and that. That is why we have magnesium chloride like this. So your ability to draw this is what we call the lowest dot structure of ionic compounds. Thank you for watching this video. Try to subscribe to this channel, follow the video, watch the next video. I'm going to explain in the next video the concept of what we call lowest dot structures for various molecules. Thank you.